Friends, we are dealing with the topic of air conditioning known as compressor. The purpose of a compressor in HVAC system is to circulate and compress refrigerant, a substance that absorbs and releases the heat, thereby enabling the system to cool or heat the air. An air conditioner compressor is the most vital part of the system because it facilitates the cooling cycle by circulating the refrigerant to all other parts of system. Specifically, the compressor increases the pressure and temperature of the refrigerant as it receives electrical energy to rotate from electrical motor. Friends, as intimated to you earlier, compressors are vital part of heating, ventilation and air conditioning systems, serving as a heart of the refrigeration cycle. They work by compressing refrigerant gas, raising its temperature and pressure, which is then cooled and condensed to regulate temperatures within the space. There are various types of compressor used in HVAC industry, each with its unique characteristics, advantages and ideal applications. In this blog, we will explore the main type of compressor used in HVAC systems and provide a comparative analysis to help you understand differences and applications. Five types of compressor are normally used. First one, the oldest, reciprocating. Second, rotary type. Third, screw type. Fourth, centrifugal type. And fifth, scroll type. Friends, once again, we'll discuss compressor types. As shown in this chart, compressor types are mainly of positive displacement or dynamic type. The positive displacement type of compressor are reciprocating and rotary, whereas dynamic type are centrifugal and axial. In the reciprocating category, we have single acting, double acting and diaphragm type. In the rotary application, we have lobe type, liquid ring, screw and vent type. Above diagram shows all types of air, gas or vapor compressor, but HVAC uses only gas compressors of 5 type as already shown. Friends, this particular picture shows 6 most popular types of compressors. First one, reciprocating compressor, scroll compressor which is vertical, reciprocating is horizontal, centrifugal compressor showing the motor and compressor portion, reciprocating compressor of another view, rotary vane compressor and screw compressor. Friends, this picture shows the 5 different type of HVAC application compressors. The modern type. This is reciprocating scroll type. This is rotary type. This is screw centrifugal multi-stage. And this one is rotary type. Friends, we already know five basic type of air compressor. These types are further classified by number of compression stages, sealing method, cooling method, drive method, that is by whether by motor, engine, steam or other. Lubrication method, oil free lubricating systems, package and custom built. Friends, now we are discussing reciprocating compressor. Reciprocating compressors are commonly used in residential air conditioners, refrigerators, and small commercial system HVAC systems. They operate using a piston cylinder mechanism where the piston moves back and forth to compress the refrigerant. This type of compressor is known for its robust design and reliability. Advantages of using reciprocating compressor are high efficiency at lower loads, simple maintenance and repair, suitable for small to medium cooling capacities. Whereas the disadvantages are they tend to be noisy, limited efficiency at higher loads, larger physical size compared to other types. Friends, this diagram illustrates working of reciprocating compressor where the piston at this position is shown, and when it is taken up it is compressing. This is the compressed portion, this is remaining. So you can see how the piston, this is the piston, has compressed the refrigerant air into V2 P2 from previously when it is V1 P1. The piston is connected to crankshaft through connecting rod. Further on reciprocating air compressors. Reciprocating air compressors are positive displacement machines, meaning that they increase the pressure of the air by reducing its volume. This means that they are taking in successive volume air which confined within a closed space and elevating this air to a higher pressure. The reciprocating air compressor accomplishes this by piston with a cylinder as the compressing and displacing element, and that 1 to 50 HP are typically for reciprocating units. Compressors 100 HP and above are typically rotary screw or centrifugal compressors. Classification of reciprocating compressors based on number of stages. They can be single stage or two stage. Uh, Normally commercially available. Single stage compressors are generally used for pressure in the range of 7 bars, 7 times atmospheric pressure. And two stage compressors are generally used for higher pressures in the range of 7 to 20 bars. Further on reciprocating Type compressors. Reciprocating compressors suffer less efficiency loss at partial load than other types, and they may actually have a higher absolute efficiency at low loads than the other types. A smaller reciprocating compressor control output by turning on and off method. This eliminates all part load losses except for a short period of inefficient operation when the machine starts. The reciprocating compressors uh, are classified based on their sealing method. The first one is open reciprocating compressor. Second one is semi-hermetic reciprocating compressor, this portion. And third is hermetic reciprocating compressor. Now we are discussing rotary compressors. Rotary compressors are often used in residential and light commercial air conditioning systems as well as in heat pumps. They use rotating element to compress the refrigerant. They come into two types, the rotary vent type and the rotary screw compressor. The rotary vent type uses blades mounted on a rotor, while the rotary compressor screw type uses two interlocking helical rotors. Advantages: compact design, quiet operation, high efficiency at partial load. Disadvantage: a higher initial cost, requires more precise manufacturing tolerances. We are discussing now rotary screw compressor. Rotary screw compressors are one of the most commonly used compressors because they don't require extensive maintenance and have an internal cooling system. The rotary screw type of compressor are large compressors that can either run oil free or be lubricating using oil. The compressor have two internal rotors responsible for generating energy within these. The pressure builds up when the air gets trapped between the opposite uh, rotors. It features an internal cooling system that can function within a range of 5 to 350 horsepower. Friends, the screw type compressor shown in the diagram on right hand side bottom. Screw compressors are commonly used in large commercial and industrial applications such as chillers and refrigeration systems. Also known as helical compressor, they use two meshing helical screws, one, two, to compress the refrigerant. These compressors are known for their ability to handle large volumes of refrigerant and their efficiency over a wide range of operating conditions. Advantages are high efficiency, especially at high load, reliable and robust, lower maintenance cost. Disadvantages are high initial cost and large physical size. Friends, this shows the opened up details of screw compressor of large size. Once again into screw compressors. Screw compressors, sometimes called helical rotary compressor, compress the refrigerant by trapping it in the threads of a rotating screw-shaped rotor. Screw compressors have increasingly taken over from reciprocating compressor of medium sizes and large sizes, and they have even entered the size domain of centrifugal machines. Screw compressors are applicable to refrigerants that have higher condensing pressures such as HCFC 22 and ammonia. In a compressor, there are male rotor and lobes and female rotor with gullies. As both of the rotor rotate in opposite direction, the the gas gets drawn in, gets sealed between the rotors and housing, gets compressed as the cavity bears against the end of housing, and finally, as the screw thread reaches the discharge part, the compressed gas flows into the discharge line. This compression ratio in a single stage can go up to 25 to 1, which is significantly higher than the pressure ratios of reciprocating compressors. Screw compressors are available for refrigeration capacities from 10 TR to 1200 TR, but commonly used in 100 to 300 ton range. The diagram shows here the working of screw compressors. Due to internal losses, capacity control by sliding valve below 60% capacity is not very efficient. However, a screw compressor can tolerate liquid slugging like this. Friends, the characteristic features of a screw compressor. First, most commonly used in water chiller ranging from 70 to 450 ton. Improved reliability and efficiency over reciprocating compressors. Third, works in principle of trapping and compressing refrigerant vapor of positive displacement compressor. Friends, now we are discussing centrifugal compressors. Centrifugal compressors use a rotating impeller to impart velocity to the refrigerant, converting kinetic energy into pressure. They are typically used in large commercial and industrial HVAC systems such as chillers for large buildings or industrial processes are known for their efficiency in large systems. Advantages: high efficiency at large capacities, low maintenance due to fewer moving parts, capable of variable capacity control. That is the biggest advantage. Among the disadvantages, first, high initial cost and complexity. Second, requires precise manufacturing and maintenance. Third, large physical footprints. Friends, this we have already covered. Friends, once again into centrifugal compressor. Centrifugal air compressor is dynamic compressor which depends on transfer of energy from a rotating impeller to the air. Centrifugal compressors produce high pressure discharge by converting angular momentum imparted by the rotating impeller, that means dynamic replacement. In order to do this efficiency, centrifugal compressors rotate at higher speeds than other type of compressors. These type compressors are also designed for higher capacity because flow through the compressor is continuous. Adjusting the inlet guide vanes is the most common method to control capacity of centrifugal compressor. By closing the guide vanes, volumetric flows and capacities are reduced. The centrifugal air compressor is an oil-free maintenance oil-free compressor by design. The oil lubricating running gear is separated from the air by shaft seals and atmospheric vents. Friends, centrifugal compressors have a single major moving part, that is an impeller that compresses the refrigerant gas by centrifugal force. The gas is given kinetic energy as it flows through the impeller. The kinetic energy is not useful in itself, so it must be converted to pressure energy. This is done by allowing the gas to slow down smoothly in a stationary diffuser surrounding the impeller. To minimize efficiency loss at reduced loads, centrifugal compressors typically throttle output with inlet guide vanes located at the inlet to the impeller. This method is efficient down to about 50% load, but the efficiency of the method decreases rapidly below 50% load. Friends, in this centrifugal compressor, large volumes of vapor are centrifugally accelerated to high velocity, and this velocity energy is converted to pressure energy. The compression ratio is around 5 to 1 at 3600 rpm. The speed of the centrifugal compressor goes very high at around 20,000 rpm also. These machines are uh, manufactured in the range of 35 to 10,000 ton capacity. Centrifugal are generally used beyond 150 ton single machinery capacity. In centrifugal compressor, capacity control is usually by inlet guide vanes at this section. Con- Capacity control in the range of 100 to 100% is possible. Friends, next compressor is scroll compressor. The scroll compressor is an old invention that has finally come to the market. The gas is compressed between the two scroll-shaped vents. One of the vents is fixed and the other moves within it. The moving vent does not rotate, but it does center revolves with respect to the center of fixed vent. This motion sequences the refrigerant gas along a spiral path from the outside of the vents towards the center, where the discharge port is located. Friends, now the characteristic features of scroll compressors. First, very common compressor used in HVAC marketplace. Second, very reliable, less moving parts. Third, it is efficient. Fourth, works on the principle of trapping and compressing refrigerant vapor, that is, it is positive displacement type compressor. The two-stage compressor. First, it is available in 2 to 6 ton nominal. Second, uses two internal bypass ports to enable the system to run at approximately 67% part load for improved efficiency and humidity control. Third, stage 1 and stage 2 determine by pressure differential that instantly shift between full load and part load capacity. Fourth, slight increase over standard scroll compressor up to 5.5%. Friends, the figure here shows a scroll compressor.